Let's consider variable scope. The scope of a variable is where it is recognized. Let's see what we mean by that. We have here a function. We've got two functions, dodo and edo. And you've got the prototypes here, of course. And we call each of those functions. Nothing really very unusual, but in here we've declared a variable integer I, and here we've declared integer j. Let's see if that works. So that's fine. We've printed out the value of I, which is 1, and the value of j, which is 2. I and j are separate. What I mean is that if I try to print out j within this particular function, you can see that straight away you're getting an error. This means that j is not known in this function. We say that j is local to this function here, and I is local to this function here. So we simply cannot have j being referred to in this function here. Let's consider though that if we had a variable which is the same. So you have here I here, I equals 2, and then you print out I. But what we want to do is to make sure that I is known throughout the whole program. Well, what we do is to declare our variable outside here, so that we can say int I. So this is called a global variable, or a global variable we'll call it. Okay, that means we don't need to declare our variable inside our functions. Now these functions, if we'll just build this, and run it, and you'll see that I has got the value of 1 and 2 as before, but these are one and the same. So for example, if you could try this, if I were to increment I in here, then it would increment I in there. Well, why don't we try just printing out, if we have dodo is called first, so let's just get I equals 1, so that, and we get rid of this, and maybe I could increment I in here. And then build this and run it. You can see that I has got the value of 1 and 2 because we print out the value of 1, but in the next function we increment I and then print that out. It gives you the value of 2. And that's because we've used an external variable here, which is a global variable, I should say, which is known throughout the whole program. In particular, I will be known throughout these two functions. Now you might say, hey, this is great, I'm just going to use external variables all the time. Well, not a good idea, and the reason is that you might have a program which has got thousands of lines of code, and if you go declaring external variables, you really don't know where the variable is getting changed. So it can cause error, but not only causing error, you might not know where the error is. It could be anywhere, but if you declare your variables locally, then you've got a much better chance of finding where your errors are. We're just talking about where a variable is recognized. I want to show you how it's remembered when a function is called again. I have here therefore a static. I've declared a variable int as being static with the value of 3. Well, what will it print out? It's going to increment the value I and then print out the value of I. Let's just see what happens. Well, it's 4 and 5. Now let's single step that. I'll put a breakpoint here and run the code, and here we are. We're about to call our function, so I'll do an F11. Now take a look. I has got the value of 3. We're all happy with that. Now I gets increment and becomes 4, but here's the bit that is difficult to comprehend really. if you look back here, I has got the value of 4. It's been incremented. So even though you're specifically saying it's 3 here, it's going to be incremented to 4. So if I do, be careful, I'll do an F10, and that prints out the value of I here. And then I F11 to single step, and then I call it again. Now when it calls again, we're in for a shock. Let's take a look at the value. I'll just press F11 again. We're in for shock because I has been remembered. So that's really the meaning of static. It remembers it inside the function from the last time around. So what do you think is going to happen now? If I do I++, what do you think is going to happen? I will be increased to 5. And then we're going to carefully press F10, and that will print out the value of 5. So you can see what it does. Static means please remember what the value of I was from before. Even though I'm saying it's 3, you can ignore that. Static means it will be remembered. Now, I couldn't think of a worse name to call something because it's the opposite of static. It does not remain static. It gets changed when the function is called again. I want to return to the idea of passing by reference and see if we can make any use of it. Here's a straightforward passing by reference. We define our integer I and we pass it to the function here, which is we've called an A, and we've given it a value in here. Well, perhaps I better give it another value. Well, what if I don't define? I'll give it another value in here, say 5. Now, so what happens? Can you predict what's going to happen? Let's just build it, and then can you see what it's going to output here as the value of I? 5. Remember, passing by reference means that if you pass that in all good faith to there, and when you change it, the original gets changed. We've done this before. We single-stepped and showed that this value is increased to 5. You might think that's a bit weird, actually, but let's see if we can take advantage of that. What I'd like to do is declare a variable here, j, and then I'd simply like to print out I and j. We can just ignore the function call, just looking at these two bits of code. Let's see what they do. It simply prints out 4 and 5. If I got rid of this, you might see more clearly that it just prints out 4 and 5. Right, with a line in between. So that's fine. We've got 4 and 5. Now, here's my problem. What I want to do is to print out I and j again down here. But what I want to do is to swap the two variables. So it should produce 4, 5. So what I need to do in here is to make some code to swap them around. But I need to pass two, so I'll leave you to have a go at that, and then you could come back and see how it's done. Well, first of all, we need to pass two variables, so let me just put another variable. We can call that b, for example. By the way, that ampersand can be placed like next to the a and so on. It doesn't matter, but usually we do, when we're passing by reference, we do that. Well, notice that this is complaining up here, my prototype, so I'll need to put another provision for another integer. So that's working fine, but this is not. So I'm going to pass two variables this time, I and j. So far so good, so you can build that if you wish to make sure it's building properly. Okay, what we need to do is to write some code in here to swap the two around, the a and the b. Do you remember how to do it? We need a temporary variable which we'll call t. Then we simply need to say a equals b. That's the intuitive thing to say if you're going to swap them. But what has that done? It's destroyed a. So we need to, first of all, save a in t. So we say t equals a. Then we need to restore b back to t. So if we say b equals t. So this is the standard code for swapping two things around. Now let's see if it works for a start. And if we run it, 4554, well, I think I probably should have another end line here, would be nice. And let me run that. You can see now that we get 45 and then 45 from here and then 54 from here. Well, how did it work? We passed by reference, and what that means is the values actually get changed. The a and the b get swapped around here within this code. But what that means is this value I and value j here are swapped. A little bit tricky to understand, but I assure you that's what happens. These two get swapped around. Maybe we could try doing a single step. So I'll run the program down to here, and now we can see the value of I. This I is 4, and the j is 5. So if I press the F11, it takes me here, 4 and 5, as expected. Now this code does all the swapping, and when it comes back, you can see that I is 5 and j is 4. And if I then continue F11, now be careful, F10, it prints out the two values of I and j somewhere behind here, and then I continue on, and it prints out 4 and 5 here, now 5 and 4 there. So that's how you take advantage of passing by reference, because when a function can only return one value. So this is the way you can get around it. You pass two values by reference and they get swapped around, and so that's how you swap two variables.